let's get started with today's show. Daniel, welcome to the show.
Thank you very much for having me. Really awesome to be here.
So it looks like you're in London. I haven't lived in London quite a few years myself. I recognize that curve in the Thames.
Yeah.
But I believe you're in Berlin, but you're back in London for a little bit.
Yeah, back in London, just seeing family, and we're actually going on a holiday on the East Coast. So yeah, having a bit of vacation, but certainly time for an interview still.
Very, very good. Yeah, I appreciate you taking the time. So Daniel, as always, we start these interviews. Give us a little bit about your background, because I know you got a pretty interesting background.
Sure. Yeah. So well, actually, firstly, I did mechanical engineering, and this was at Imperial College. Realized quite early that this isn't really what I'm interested in. Engines and everything are cool, but I was much more interested in robotics and 3D vision and things like this. So tried to kind of move into computer science by doing some robotics projects and 3D vision projects, which were kind of partially self-supervised. Luckily, was able to then leapfrog into a computer science PhD. And then it was here doing 3D vision and robotics and things that I then basically started to get the motivation for building Ivy. I'm kind of branching in, expanding the question a bit here to kind of personal background and origins of Ivy, so hopefully that's okay. And basically, the kind of context for that was I had noticed that in the research lab I was in, people were using a mixture of TensorFlow, PyTorch, new people using JAX, some were using Chainer, some people using Caffe who'd been there a while, and everybody doing 3D vision robotics. I basically realized that everybody was implementing independent tool sets. We all needed the same kind of functions, and therefore it was useful to be able to create libraries that everybody could use interchangeably. And then this kind of gave the motivation for Ivy, which is the abstraction layer that makes the creation of these libraries possible. So that's a kind of quick background and slightly quick origin story of kind of the motivation for Ivy initially.
Yeah, and you kind of touched upon it there. Before we get into the details of Ivy, just for the benefit of our audience, because at ODSC, we always say it's like when you become a machine learning engineer, data scientist, it's a bit like drinking from a fire hose, right? Like you need the data expertise, you need the coding expertise, you need the mathematical expertise. And then once you get through all of that in university or your boot camp or whatever, now you're looking at all these frameworks and people are always asking us questions. Should I learn TensorFlow over PyTorch? Should I learn Python over R? And, all these tools have a need, but just talk us through in a little more detail. You've already kind of given us an intro to the ecosystem out there, and you mentioned Chainer and a bunch as well. So like really talk us through a little bit more of how you found the ecosystem and
sure.
You talk about in your book about, I love the term, not your book rather, I was looking at the Ivy documentation the other day on your website, the machine learning explosion, and literally
yeah, so it's kind of interesting. I mean, as far as I can see, at least, I think NumPy was essentially the standard in Python array computing. There's obviously Pandas and scikit-learn as well, but there was kind of one dominant array processing framework since like 2006. And obviously with the advent of deep learning, with the 2012 kind of boom, there's been a whole load of activity, making heavily parallel high performance GPU array libraries and so on. And this has kind of been, something that I would say is a bit of an explosion. And there is now lots of people trying to do the same things in slightly different ways. I wouldn't say that, but by no means are TensorFlow and PyTorch and JAX kind of just different instantiations of the same thing. I would say that TensorFlow 1 was really kind of a huge impact. I used TensorFlow 1 extensively, but obviously wasn't quite that Pythonic. There was the static graph. PyTorch came along and had kind of fully eager execution and asynchronous execution on the GPU, which was a huge enabler for debugging in a much more intuitive way. TensorFlow 2 is kind of caught up with that. Then JAX has much more flexible gradient computation, is kind of much more high performance with TPUs. So I think like there's been lots of things that have had their entry point and that they've been made for a reason. It's not just like, hey, we're gonna make the same thing again just for the sake of it. But this has now led to a slightly unfortunate situation for general practitioners entering the field where it's like, what the hell am I looking at? There's so many things like, I want to use a DeepMind model, but these are using this. And it can be a bit overwhelming, I think, for people entering into the field. So this is kind of my take on that, I suppose, and how it's.
No, I think you've definitely got I think it's an industry consensus as well, because that explosion, kind of like the universe, will definitely continue to expand, and not so much as you mentioned, because any of these tools are not filling a need. It's just that the use cases for AI keep expanding with it, right?
Yeah.
So before I was in TPUs, then going to GPUs, then go to CPUs.
Yeah.
And I think the stack is getting more sophisticated. And I think another driver as well, which people don't bring up a lot, is we're moving from machine learning, data science focus to other kind of key users.
Yeah.
Right. I see new tools coming out for debugging and feature stores and things like that.
Yeah.
So I think definitely the machine learning universe explosion will continue.
Yeah.
New roles are going to require new tools, new frameworks.
Yeah.
And I think that's what kind of makes this exciting. It's overwhelming. It can be overwhelming to our community and to our audience, but that's what we love at ODSC. You look at our website, you see all those open source logos up there, and we try and cover all the bases.
One thing I was going to say is I think on top of that as well, I think hardware is another kind of separate thing to frameworks in a way that could also see their own explosion. And there's Grok, there's GraphCore, obviously like AMD, Intel, and NVIDIA are all exploring in this space. And I don't see any sign of being like a complete monolithic hardware, TPUs, IPUs, and stuff. So I think having a shared language and a shared interface that makes all of these things fully jointly workable, and being able to plug any of these things into legacy code and new code for all frameworks is another angle. But that's interesting.
And I think, and again, just to add on, I think you're on the right path, because I was at NACO in Seattle last month. A lot of talk about there and looking across common benchmarking, common standards. Onyx has been out a good couple of years.
Yeah,
not good stuff, but we can get back into that. But I definitely want to go to let's talk a little bit more in depth about Ivy.
Sure.
And for those of you who don't know, Ivy's I'll actually let you introduce where Ivy lives, get up project and all that stuff. But I definitely want to talk about what makes that framework agnostic. So
yeah,
give us a little bit more background on Ivy, and then talk about the architecture behind it that makes it framework agnostic.
Sure. So Ivy actually has its abstraction layer at the functional API level in Python. So we don't go lower level and make any assumptions about kind of whether it's XLA under the hood or C++ and CUDA or TorchScript or whatever. We basically implement Ivy's functional API, which I should also say fully adheres to the Array API standard, which is part of the consortium for Array APIs from Quansight. So this is a standard that's been kind of agreed upon by some of the biggest players in the field, like some of the top NumPy contributors, etc. So we're not reinventing a wheel there. And basically, the first thing is that we have a functional API which has one set of call signatures and syntax, and then you can choose the backend and call these functions with any backend. And we don't go any lower level than that, which arguably removes a little bit of control for the optimization, but I think is a good balance, which enables us to future-proof ourselves quite strongly, because I think kind of Array APIs are here to stay and will remain important interfaces for users to create new things. And the less we assume about the low level, the better, I think, because we can then kind of adapt whatever comes along and put them all inside our ecosystem as well. So yeah, this is basically how it works. And everything else in Ivy, the framework, just to add on that, is built on top of Ivy's functional API. So in a similar way to how Haiku builds on top of JAX, Ivy is fully functional by design. So we always explicitly pass gradients and variables, and then all of the high-level modules are kind of just built on top of Ivy's functional API. So that's a bit of a context on the design.
No, and a couple of things. Reason why I'm a big fan of Ivy. Right now I believe you're covering from your. And by the way, I think we're going to share the link for Ivy on our chat there. If,
awesome.
Here, you can share that link to the website. But you're covering JAX, PyTorch, TensorFlow, NumPy, MXNet. So you're covering all the major frameworks. Which is awesome. And the big thing I like about it, it's like all those frameworks are kind of they're competing against each other, right? Whereas Ivy is a framework that's actually complementary to all these frameworks. So I think that's, if you want to elaborate on that, I think that's this really distinction for people to understand.
But that's a good point, actually. So by design, we certainly don't want to try to just say, hey, everyone, drop everything you're using, use Ivy now, because now you can support all frameworks. Very much the design is that we kind of just want to make it a bit easier. So if you want to use a single Ivy function in your PyTorch project, you can do. If you want to write the whole thing in Ivy and use our whole data loaders and trainers, we also have those. Similar to PyTorch Lightning, we have our own builder repository. So if you want to become hardcore 100% Ivy, you're welcome to. But I think we have much more impact by enabling people to just kind of, take a few functions from here and there. And I think actually this will then touch on to the Transpiler a bit as well, but I won't get ahead of myself. But so very much Ivy is designed to be used 1% in the code, 10% in the code, or 100%. It's really something that's complementary to everything that exists, and therefore just supplements everything that's already out there.
Yeah, and you mentioned sorry, you just brought it up in conversation there, the array API standard. So just so our audience that. So I know that's it's an open source standard. A lot of companies are getting behind it. Some big companies, Meta, Google, DE Shaw, the quant shop out of New York or wherever they're from. And just talk a little bit about that, because this means it's not just supporting the deep learning frameworks.
So I think one first point is that I think there is a fair kind of concern or criticism. I've forgotten the name of it now, but the XCKD, this kind of really famous comic about creating a new standard and just making the problem worse, which is a legitimate thing. And it's quite a common thing people show, and it's kind of fair enough. And I think our response to that generally is, well, first of all, as we've just discussed, Ivy is complementary, so it's not trying to compete with other standards. It's kind of just slotting inside alongside them. But also, we aren't creating a new standard. There is a very well thought through, very well written and detailed standard already, which is the Array API standard. And we want to adhere to that because they share the same unification and kind of, they clearly share the same frustration that we have with creating Ivy, and they've written about this very well in their own blog post as well. And therefore, it's very much a complementary piece of work that we should kind of support them with and adhere to that. And then others are also moving in that direction. So I do know that PyTorch, Jax, and TensorFlow and NumPy has now an Array API sub-module. So there is efforts to conform towards that. So and I think, and the other point is that Ivy is an array computing framework. It's not just a deep learning framework which has convolutions and layers. It's kind of a very broad, general tensor computing framework. And this is what the Array API standard is about as well, or array computing, I suppose they would say.
Yeah, exactly. And I think standards may be a bit of a boring topic, but just for our audience, those of you who are code centric or data scientists, it's you said 2012. We started ODSC in 2015, but we're doing stuff before that. So it's about mid then. So we're about 10 years into it. So it's getting mature. So there's a lot of legacy code out there, and that's why a lot of problems we see in machine learning are solutions looking for a solution. We've already gone through it in the software development work. So standards are super important in software, because just imagine your colleague walks out the door and you've been handing a bunch of legacy code. You're going to start care about standardizations. In software you have re-implementation, refactoring. It's spent half my life refactoring code, which is no one wants to be refactoring. So let's talk a little bit about why you're trying to unify these, what's motivating behind some of them.
So I think so legacy code is definitely a really important angle. I guess even more immediately than that, just to enter is so even aside from legacy code, one very clear use case is doing rapid R&D, whereby you want to pull the latest version of a model from DeepMind's repository. You're a PyTorch user, your whole pipeline's in PyTorch, and then you want to just be able to take something from another framework with the guarantee that it's identical. So state-of-the-art research and quickly trying this in your research lab or in your company is one thing we want to enable without needing to do re-implementations. I think legacy code is also something whereby I guess code becomes legacy for two reasons. One, because the tooling goes out of date, and then it's just hard to kind of integrate it. And also with something that's as fast moving as AI, a code can become a legacy also just because the actual theory and the code itself is a bit old, and the actual network design and stuff. But I think even in that second case, even if even if that is the case, and therefore kind of isn't code that's going to be giving you state-of-the-art best results in your product or your research, being able to kind of get it across as a starting point and as the beginning for then building upon is a really useful thing to be able to do. So if you're in a company and you've got like code that used to be in TensorFlow 1 and now you want to start building up in PyTorch, people will often just kind of start again from scratch and re-implement it all from the beginning. And we're seeing this a little bit in JAX. JAX is a really awesome framework, but the high-level tooling and the ecosystem is not anything compared to PyTorch. And we're seeing a load of repositories appearing that are kind of doing like Torch Vision, but it's now JAX Vision or Flax Vision and things like this. So I would say that legacy code, even if it's theoretically out of date, then it's still really useful to be able to bring it forward and then build upon it. And it just saves a lot of re-implementation effort. I kind of meandered around a bit there. I hope that was somewhat coherent. Feel free to pry in more and I can kind of dig a bit deeper.
Yeah, but so, full disclosure, I'd love to spend more time on Ivy, but I think I did about a month ago. And one of the things that really surprised me was, because I've used TensorFlow, I've used PyTorch, and never really thought a whole lot about before, but there's a lot of commonality between the functionality in both, right?
Yeah.
Haven't got a chance to play with JAX. I barely remember MXNet. Mm-hmm. So I think that's important for people to understand that you're not building an API framework that's fundamentally different from the underlying one. So if you can talk to that a little bit, because that's what makes it, it's pretty easy to get started with something like that.
Yeah, absolutely. So I mean, first of all, I would say, there are differences. I don't want to kind of undermine the significance of VMAP and PMAP and JAX and other kind of unique features. But in general, since I would say NumPy 2006, even probably before that, that's just kind of the reference point I'm using. But obviously, the fundamental operation used to perform on a matrix and a tensor are kind of mathematically derived and are consistent and well-defined. And we just see different instantiations of the same kind of API, where the differences predominantly are in the names or the call signatures and the argument names and just kind of these like relatively insignificant details. Under the hood, the actual operations that these frameworks support, like matmul and transpose and reshape and element-wise mathematical operations and so on, are all the same because it's kind of rooted in maths, obviously. So, and this is therefore why this is also why the functional API was the level of abstraction at which we decided to try to unify things. One, because it's intuitive and quite simple to kind of get your head around, and two, because it's kind of fundamentally persistent. It's just kind of at this functional API, we're going to need to continue having APIs that look something like this, and therefore it's kind of future-proofing stuff a bit. And sorry, I'm expanding your question into some other questions that I'm maybe.
No, that's perfect. That's perfect. So,
sure. So what I was also going to say here is that another good thing about the functional API abstraction is that because it's a like user-facing API, there are very strong internal incentives for all of these frameworks to have very strong forwards and backwards compatibility requirements, because all of their own high-level classes and tooling are built on top of the functional API. If they want the ecosystem that's built around these frameworks to remain working when they update the next version, there just needs to be very strong requirements for things to be very stable. So this makes our lives easier as well, because it's not like a question a lot of people ask is, isn't this going to be a nightmare to maintain all of the different versions of all the different frameworks? And actually, not really. Since the last 2 years, when starting, not once has a unit test, maybe once or twice when a namespace becomes deprecated or something. But generally speaking, I can't remember any occasion really where I've had to change things in the unit test because of a new version of any of these frameworks. So kind of once it's done, it's done. And this is another reason why abstracting the functional API is a much better idea. It's much better to do that than abstract higher level up on top of the classes, which are a little bit more turbulent and see more changes. And it also, it also gives you more control, obviously. I think Keras did have a functional API, but it was a bit more high level as a comparison. And Keras, therefore, wasn't really about low-level full control, but more kind of really useful, quickly prototyping things that follow a certain pattern. Whereas with Ivy, given that we go right down to the functional level, you can kind of compose things with full control, basically. So these are just some things around this abstraction layer and function API. Again, I might not have answered the exact question.
No, and this is great detail for our audience. But one thing I know you and your team are pretty excited about is Ivy's a transpiler. So for our audience, first, can we explain to them your definition of what a transpiler is, what it does, and why it's kind of a big deal.
Sure. Well, to be honest, I didn't know the word transpiler. I kind of Googled around to see what we were trying to do and if there was a word, and that was the closest I found to transcompiler or transpiler. So basically, what the Ivy transpiler is doing is enabling any code. Well, I was taking a step back actually. So actually, originally with Ivy, I on the first instantiation of this, there was no idea of having the transpiler. I basically was doing something that was actually very similar to eagerpy, another really good relevant piece of work, which is just to create the functional API. And the motivation was everybody can now start writing their libraries and their models in Ivy, and then we can all run it on any backend, and it's great. And I think that has a selling point, but it means that all of the stuff that's already out there can't benefit from Ivy unless they re-implement the whole thing in Ivy. And this is, not realistically going to happen unless Ivy gets lots of momentum. So we were then thinking, well, it would be much nicer if PyTorch Geometric or Cornea or kind of, list any other really good open source frameworks, if they could then, without them needing to do anything, suddenly market all of their functions and models to JAX and TensorFlow without them needing to do anything. And can we kind of solve that for them? And then this is where the transpiler point came, and there is ONNX and other things that do this deployment, but to do this for full flexibility at training time, what we do is basically take any code in any framework, decompose that into a computation graph, which is a fully functional computation graph, and then we take each of those functions, convert them to Ivy functions, and then convert those to the backend functions. So
sounds complicated, but you're doing the heavy lifting, so that's perfect.
Yeah, and I can expand on more of that. I don't want to kind of pad out too far, but basically it's enabling us to take code in one framework, convert it to code in another framework without you needing to do anything. Basically,
that's the key point. Yes.
Yeah.
And
exactly. So probably should have started the answer with that point.
That's pretty cool. So that's super exciting, and I can't wait to play around with that myself. So just a reminder to our audience: please post any questions you may have in the chat window there, and I think we do have one from James Keane.
Oh yeah,
and he says, I can read it out. Hi, there it is. Hi, won't the APIs of all frameworks eventually converge anyway and make it redundant?
Yeah, so that's a really good question. So there's a few points here. One of them is that it's very hard actually for these frameworks to have their APIs converge quickly because of these very strong forward and backwards compatibility requirements. So if suddenly the APIs of all these frameworks completely change to be this new one, then all of their high-level code, all of the libraries in the ecosystem would break, basically. So this is one point here. And there's no sign of this happening quickly at all. And even then, it would still not solve the problem of kind of legacy code and all the code that's been written today. So all of these, even if PyTorch or TensorFlow now suddenly had this new API, it wouldn't suddenly mean that all of these huge repositories, like PyTorch Geometric is one I use because it's very good. There's many others, wouldn't then suddenly be working with this as well. Whereas Ivy doesn't require buy-in. It kind of enables everything that's already been written and will be written to be jointly convertible, which is something that just changing the API won't solve. So this is kind of, I think, the biggest response to that. And also obviously with things like Julia and Dex, there's lots of things that will come out that you end up needing everybody to buy into the exact same API, which doesn't seem like it's happening. So I don't think it's a big risk in the short term.
Yeah, and from my experience, limited experience or extensive experience, but I'm not trying to bias my own experiences, but I've definitely seen attempts in that in the software engineering side and the engineering side, and it's always run up the same problem, like even with standardization, number one. And then number two, I think there's a fundamental difference between traditional rules-based full stack software engineering versus let's call it machine learning engineering, very data centric, model centric. At the end of the day, it is all running code. You're not dealing with visualizations and front ends and stuff like that so much. And so I think there's a much stronger need and a much stronger possibility that something like Ivy can be hugely impactful. I think, it's already pointing towards that because you've got some really good traction on great GitHub. Do you want to talk about that for a minute? Because
sure. Well, sorry, let me cut you off. That's something that we're really happy about. To be honest, so in February we had 180 stars or something, and kind of maybe 10 contributors. There's a few factors here, one of which is I think the story resonates. We kind of very strongly clarify. I mean, the website has gone under a big revamp, and the README and everything. We're putting a huge amount of effort into making sure the contributor guide and the YouTube tutorial series and things like this are as clear for anybody in the wider community to engage and to meaningfully contribute towards what we're doing. So I think this has really resonated with people that want to get involved, and we're kind of very welcoming of contributors. Another thing is that we are doing internships, and we've reached out to quite a lot of universities, and a lot of people found out about Ivy that way, and I think kind of word of mouth spreading is going around. Yeah, but to be honest, just to that point, with regards to the Transpiler, we are still kind of ramping up to the first full demo of the Transpiler. So in some sense, I mean, Ivy is a working framework, and we have like version 1.1.9 released actually late last year, before we got this traction. But we're currently in the process of getting version 1.2 released. So there are some breaking changes as we're ramping up. So in some sense, we're kind of pre-product, and we're not kind of really encouraging everyone to try it. So I think people just like where we're going in the story, and that's really, I guess that's really reassuring that that this is.
The direction's good. Yeah, I completely forgot about it, but I wrote a blog a few days ago. It was on you'll see it on our ODSC website, our Open Data Science, our blog site. It was top 12 open source machine learning projects 2022 so far. So all I did was look at the stars from the beginning of the year versus now, and
yeah,
sorry to say, Danielle, but DALL-E and the last selfie ever taken by a human is kind of overtaken.
Oh no,
Ivy, but that's okay. This DALL-E Mini's kind of taken off, and Hugging Face Transformers is above you. You're right there in the middle, so it's amazing traction you've gotten from the community. At the end of the day, it's community endorsement of what you're doing here. So yeah, congratulations on that.
No, another thing to say as well, let's just quickly add on to that, is I think this is also really a self-fueling process, because the number of functions that need adding is quite substantial. We need quite a lot of front-end functions, a lot of back-end functions. We've kind of got all of these open tasks for everybody in the community to engage with, and people are engaging. Some of them are engaging as part of applications, others are engaging because they just want to be involved. And yeah, I think Ivy only succeeds with a community effort, because I don't think we can just do it on our own. So I think it's quite nice that this is something that can be a success because of the community, to be honest, as well.
Yeah, and just to mention, those of you who are contributors or thinking about contributing to a project, this could be a good one. And then, speaking of community, I know you've gotten some, when I browse around social media, Twitter, and all that stuff, I think you've got some kudos there. So, tell us, Drew, who's what feedback you're getting from Ivy? What are the use cases you see people using it for? Who's using it stuff?
Sure. So I think so again, just to quickly say as well, that I think at the moment, most of the kind of attention around Ivy is more around the story, and we are probably before the phase where we see a ton of kind of heavy users, is one thing just to say. It has been used in some research projects, which myself and others have worked on. But I think what's resonating with most people with regards to the messages we get and the requests we get for things, for features and so on, is particularly in people that do R&D first and foremost, whereby the whole fragmented internet of functions and models is frustrating, and models come out in all these different companies with different versions of different frameworks, and they just want to try out in their pipeline, and they can't, and they need to re-implement it, or they need to wait for a new version to come online, open source, which inevitably has some slight deviations or bugs, because the devil is in the detail in ML. A slight difference in the initialization scheme can be completely different results. So people want to just be able to kind of use the Transpiler for doing R&D. But I think another thing is that we're getting more and more people asking, when's Ivy ready, so they can start writing their own libraries in Ivy, because they were doing things in PyTorch, now JAX, and they don't know what they're going to be using in the future. And if they can write their own code and libraries and models in Ivy and be quite confident that we've got them covered for kind of all the future advancements that happen, and they can just use it in whatever projects they want, then people want to write things in Ivy to kind of future-proof themselves and maximize their own audience. So these are probably the two biggest use cases. And there's some enterprise potential use cases we could talk about a bit as well. But for kind of individual users, I think these are the main two. And also,
yeah.
The other one is just opening up to all hardware. People use PyTorch. I know there is bindings to TPUs with PyTorch and XLA at the moment, which is good, but kind of a robust solution to run any version of PyTorch on a TPU is something that people say is quite exciting as well. So these are just some example use cases.
No, that's great. And so what else is in the roadmap here? Because I know you've covered a lot already. It's early, new version coming out, but
sure.
Where do you see this going?
So the first thing we need to do really that we're working on mainly right now is the first Transpiler demo. So we want to show, and actually this is going to be Perceiver.io. It's an architecture I'm a big fan of. Many people probably know about it already, but from DeepMind, a very general transformer architecture that can do kind of optical flow and all kinds of things in image recognition. So this is a really cool model, and I want to just show how you can take this off the DeepMind repository and just transpile it into PyTorch or TensorFlow. This is kind of then something we'll put on a Jupyter Notebook for everyone to try with, to play around with. But what we've also done, which is definitely on the roadmap for the end of this year, early next year, is we've reached out to a whole load of people in the open source ML space and repository creators, and had chats with them along the lines of, hey, would you be interested in maybe having some Jupyter Notebooks on the master branch, which kind of demonstrate how Ivy can open up your user base? And overwhelmingly, the response is positive. So we want to kind of really start to explore these collaborations and just kind of see how we can help out all of these repositories that are already out there, and kind of expand them to more users. And then long term, we're a startup as well. We have business model plans that we need to kind of explore on, but we're very much in the community building phase and making something that's useful in the short term.
Gotcha. And anything on the front end side doing there?
Yeah, so I mean, we are now working on the front ends, which are necessary for the Transpiler. So only recently was this made an open task to the community. As it stands, the back end is very sophisticated. I mean, it is very close to being done. The front ends have kind of only just been started, but now we're already getting a few functions added every day. Again, people in the community are helping out there. And one thing just to quickly say there, which I think is relevant, because it might seem a bit daunting that we've got all of these framework-specific front ends that we then have lists of functions that need adding on our repository. But an important point to make is that there's very much the 80-20 rule with machine learning models. So if you decompose ResNet into its constituent functions, there's like 8 functions or something. And if you do it with like a transformer, maybe it's like 15 or something. There's obviously map mode, there's ReLU, there's reshape and transpose, and there's a lot of heavy lifting functions that do a lot of the work in neural networks. So we can obviously prioritize what we support when, so we have a big impact quickly as well, which I think is an important point.
No, that's definitely important. So just like two audience questions questions would seem pretty similar. Jihad Z asks, how will you manage to keep Ivy going for so many different frameworks?
Yeah,
we're talking about that explosion.
Yeah,
and then also Cigar Matt Powell mentioned a little more deep on that. What are the challenges you're facing with keeping up with so many functions for these frameworks? Yeah,
so I think a couple of things. I think first of all, because of the strong forwards and backwards compatibility requirements of any given framework, this work very much, once it's done, is done. So we certainly don't need to add a new function. We don't need to kind of add a new Ivy function for every version of TensorFlow and every version of PyTorch. If you look at the functional API over time, it broadly stays the same across versions. So kind of once it's done, it's done. But there are hundreds of functions, but we're kind of working hard getting through them. It would just be with a combination of a continuing strong community push, which we're seeing now, and it's only increasing each week. Obviously, our team expanding as well and keeping up on top of that. But it's certainly the amount of progress we've made in the last few months after expanding the team and getting huge community engagement is kind of astounding. I mean, I think it's kind of quite amazing to see. We've now got 300 contributors, all of whom have done something meaningful and contributed towards this. So I think as long as the kind of hands involved scales, then this becomes very manageable. And again, it's not ongoing. Once it's done, kind of it is done, and then we need a new framework. But then once it's done, it's done. So that's that point. Was there a second question, or did that answer?
No, the both questions are related. And to me, it's like this project is the epitome of a great open source project, because I think there's a ton of work to do here. There's a community motivation, there's a community need. So I think it's awesome what you're doing. And
thank you.
And let me go off script here a bit, because I know, Daniel, you're in London today. Again, on the map, but you're in Berlin. I know we've got a couple of audience members from Berlin, because I saw them introduce themselves. And now I've been to Berlin a few times, and we always talk about AI and the US, a little bit Canada, the Gang of Four or whatever, China, but Berlin's it's a pretty up and coming, or if not already, center of tech, as well as I know, like, London's a great center for this as well. Not to put down Paris or other places like that, but there's a lot of good stuff has been going on in Berlin.
Seems like
it. For years now, and it's. So I think you mentioned you recently moved there. Or?
Yeah, I actually moved there. Actually, it was just because my girlfriend lives there, so there's no kind of tech attraction really. But I definitely.
Beer gardens in the summer. Beer gardens there. I've been to it a few times.
Exactly. But I love Berlin. I have to say, after having lived in London for 10 years, kind of during my undergraduate and when I was doing PhD, I love London, but I think probably somebody that's a bit of a workaholic and kind of radiates stress. I like it when the surroundings don't radiate it back towards me. So I like the kind of slightly more chilled out vibe and slightly more not disrespectful. I mean, it's a great lifestyle, but to have things a bit more slow paced works well for me when I'm kind of manic all the time, I think. So I like it a lot, yeah. And I also have noticed that there's definitely a good startup hub and VC hub. So
for sure, that's a great spot.
Yeah.
All right, everyone. So I think that's, unless anyone has any other questions, that is going to wrap up our show for today. Daniel, thank you so much once again. You are speaking at ODSC West coming up November 1st through 3rd. If you just want to mention what you're speaking on there.
Yeah.
No surprises, I think.
No. So November 1st this is kind of actually the big thing we're working towards, our first demonstration of the Transpiler for the Perceiver IO architecture. It's something that we're close to getting ready, so it's a nice. I'm confident it'll be in place, but it's a nice motivating deadline for us as well. So that's what we'll be sharing.
That's fantastic, and everyone, thank you to our audience. We'll make this available as a recording in AI Plus and other places. So do come back and check out the next interview, which will be announcing shortly. Daniel, thank you again.
Awesome. Thanks a lot.